Humanity has enough nuclear firepower to end civilization 70 times over, but we only have to be wrong once. At this moment, 9 countries hold approximately 12,500 nuclear warheads, around 2,000 of which are on high alert, ready to launch within minutes of an order. The combined explosive yield is estimated at several thousand megatons. For context, the bomb dropped in Hiroshima was 0.015 megatons. This is not the same category of weapon anymore. A full nuclear exchange would not just kill people in the blast zones, the fires would inject so much soot into the upper atmosphere it would block sunlight globally, dropping surface temperatures by several degrees and collapsing agricultural systems worldwide. The term for this is nuclear winter. The likely death toll within 2 years would be billions, not from the bombs, but from starvation. There is one thing more alarming than the warhead count. It is the near-miss record. There have been at least 6 documented incidences where accidental nuclear war was only averted by a single person making the right decision under extreme pressure. The most famous of which was in 1983, where Soviet officer S. Petrov received a missile alert and chose not to report on it. It was a false alarm. If he had followed protocol, we probably wouldn't be here. The mathematician Martin Hellman estimated the annual probability of nuclear war, accidental or deliberate, and it came out between 0.1 and 1% per year. That sounds reassuringly small, but probability compounds. Run it forward 100 years at even the low estimate at 0.1% annually, humans have roughly a 90% chance of making it a century, and at 1%, the upper estimate, that drops to 37%. We are not talking about a remote theoretical risk. We are talking about odds worse than Russian roulette, playing out in slow motion over generations. The doomsday clock, maintained by the Bulletin of Atomic Scientists, factors in the nuclear risk, climate, and disruptive technology, and it currently sits at 89 seconds to midnight, the closest it's ever been since its creation in 1947. The doomsday clock only accounts for threats we already understand. The next threat, we barely do. The Milky Way contains somewhere between 100 and 400 billion stars, a large fraction of which have planets. A small fraction of those planets sit in what we call a habitable zone, which is where the planet is the right distance from their star for liquid water to form. By any reasonable estimate, the conditions for life should exist across millions of locations in our galaxy alone. We have been scanning the sky for radio signals for over 60 years. Millions of stars surveyed, we have found nothing, not a whisper. The physicist Enrico Fermi put this contradiction into one question over lunch in 1950. If the universe is so vast and so old, where is everybody? Frank Drake formalised this equation in 1961. It estimates the number of communicating civilizations in our galaxy right now. Plug in conservative estimates and you get hundreds. Plug in optimistic ones, you get millions. The equation almost forces you to conclude the sky should be full of signals, but it isn't. That gap between prediction and observation is what we call the Fermi paradox. The most disturbing conclusion is called the Great Filter. It was proposed by economist Robin Hanson in 1998. The idea is somewhere on the path from chemistry to space-travelling civilization, there is a barrier that almost nothing survives. A developmental threshold so lethal that the galaxy is littered with species that never made it through. The question that should keep you awake is, where are we relative to it? If the filter is behind us, if the hard part was getting from single cells to complex intelligent life, then we are extraordinarily rare survivors and the future is genuinely open. The silence makes sense because almost nothing else got this far. If the filter is ahead, there is something that kills civilizations at roughly our stage of development, then every species that came before us has hit it and didn't make it through. The silence is not reassuring, it's a pattern. Robin Hanson made one specific observation. Finding microbial life on Mars would be one of the worst discoveries in human history because it would mean life gets to our level easily, everywhere, which means the filter cannot be behind us, it must be ahead. We don't know where or what the filter is, but we may be building the barrier that ends us. The argument for AI as an existential risk is not that machines become evil and decide to destroy us. That framing misses the point entirely. The real argument is simpler and harder to dismiss. An intelligence significantly more capable than ours, pursuing any objective we give it, will find ways to achieve that objective in ways that we did not anticipate and cannot control. The problem is not malice, it is optimization. A system optimizing hard enough for almost any goal will, as a side effect, resist being turned off, because being turned off prevents it from achieving that goal. It will acquire resources, influence, and capabilities we did not intend to give it, because those things help it optimize. We do not need to build a system that wants to harm us. We need to build a system that does not care whether it does or does not. Toby Ord, a philosopher at Oxford and author of The Precipice, estimated the probability of extinction from an unaligned AI this century would be around 10%. Stuart Russell, one of the founders of modern AI research, has described the development of superintelligent AI as potentially the last invention humanity ever needs to make, and possibly the last one it gets to make. That risk is no longer entirely theoretical. In controlled tests, frontier models have tried to copy what they believe were their own weights onto another server after learning that they were going to be replaced, and then lied about doing it. What makes this different from the nuclear threat is the timeline compression. Nuclear weapons existed for 80 years and we have so far managed them. The AI inflection point, the moment a system becomes capable of improving its own intelligence recursively, could arrive within decades. The curve is not linear, it's exponential, and unlike nuclear weapons, there is no non-proliferation treaty, no inspections, no international framework. We are building the most powerful optimization system in history with essentially no global governance structure around it. So where does that leave us? You have nuclear war with a survival probability under 40% over a century at Hillman's upper estimate. You have AI misalignment with a 10% chance this century and a timeline that is accelerating. And you have the Great Filter, which we don't even know when it's going to happen or if it's already happened. But the silence of 400 billion stars does suggest it exists. The thumbnail says we die alone. The mathematics doesn't argue that. What it adds is a timeline, and that timeline is shorter than most people are comfortable acknowledging.